All right, people watching this video, I got started and then I realized we have to record. So we're just previewing Chapter 3. Chapter 2, we talked about linear functions. Chapter 3, we're talking about quadratic functions. So parabolas, that type of thing, okay? Here is the rundown of the sections. There are 8 sections. After section 4, we'll be having a mid-chapter quiz. So right here, okay? Halfway through the chapter, right? Like we did last chapter, mid-chapter quiz, you get to use your notes on. So make sure that you know what you're doing. And you have all of those ready to go, okay? In section 3.1, this takes a little bit of time. We're going to be graphing quadratic functions. So like finding the vertex. What's a vertex, by the way?
The point where it's at the maximum.
Yeah, this is the maximum or the minimum. That's the vertex, okay? So we're going to be graphing quadratic functions, doing all that stuff, solving quadratic equations. We're trying to figure out where he crosses the x-axis. So like this point, or like these two places, where those are living. That's what we're trying to solve. And then we talk about complex numbers. Do you know what complex numbers are?
Hard numbers.
Imaginary numbers.
What?
Do you know what imaginary numbers are? I. Have you heard the word I, the term I before? Imaginary? Just put it on my desk. Okay. Imaginary numbers. Factoring, completing the square, finding the discriminant. We know what this is. An inequality. What's an inequality from last chapter?
A greater than or less than.
Greater than or less than. So this is probably going to involve shading of some sort. Okay. And then solving linear, nonlinear systems. So we have parabolas and lines that are going through each other and that type of thing. So we're solving those. Okay. Good. That's a preview of the chapter. We got lots of stuff going on, but after 3-4, we'll be taking mid-chapter quiz, okay? We're going to go through this chapter very, very slowly. Not a section per day, usually. Some of them might go one section per day. 3-3, usually complex numbers is usually one section per day, but we'll see, okay? Today, it's probably going to take 2 days, but I will give you a homework assignment, so let's see how we got. What?
Yes, her pretzels.
What?
Brady.
Put your pretzels away.
You come in and you cause
Yep,
problems.
you come in and you cause problems.
Real.
Okay, put it away.
Yeah, are you unconcussed yet?
All right. Do you guys, let's look. You guys are on page 142. Everybody in your book, go to page 142. It is a green thing that looks like this. Green page, like 2 green lines. We're going to talk through the quick review. Okay? Green page. Here we go. 142. It's the beginning of the chapter, right before section 3.1. Okay, and we're going to go through some examples just to kind of get us warmed up a little bit. They give us f of x is this function and g of x is this guy. So they're not calling it like y equals anymore or y equals anymore. They call it f of x and g of x. Got it? If they say find f of 2, what does that mean?
Plug 2 in for x.
Plug 2 in for x on which one?
F of 2.
The f of x right here. I'm going to plug 2 in there. Okay, so 2 goes here and 2 goes here. All right, and then we're going to solve. So negative 2, 2 squared, plus 3 times 2 minus 1. Here we go. All right. If you're going to solve this wrong, here's what you're going to do. Are you ready? If you're going to solve this wrong, here's what you're going to do. I have a lot of people that like to do negative 2 times 2 and then square that.
No.
What do you do first?
Square.
You take the 2 and you square that first, okay? So that in the order of operations, PEMDAS, the exponents come before multiplies. So 2 squared, this guy is 4. Okay, then negative 2 times 4 is negative 8 plus 6 minus 1. Okay, what's negative 8 plus 6 minus 1? Negative 3. Final answer? You can see that that's what they got, negative 3, okay? All right, they want g of negative 2. You try this one. G of negative 2.
7.
You cheated.
No. Good job, Trevor.
Okay. Negative 2, we square him first. He is how much?
4.
Positive 4. Okay, 3 times 4 is 12. Minus 5 is 7. Perfect. Okay, we're not going to do example 2. That's really hard. You guys don't know how to do that yet. And they think that you do. Okay. All right. Let's just do one of these. Let's do 4. G of negative 3. Okay? You plug in and find g of negative 3. Do number 4 real quick on that page. The answer is not provided for you. Do number 4 real quick. You don't have to do 1, 2, 3. Just do number 4, plug it in. Go. Get an answer.
Which one is this?
G of -3
I got it.
into here. See what you get.
What?
Oh.
I got it.
Damn.
Do we have homework today?
I don't think we
It's
0.
no.
It's 0.
It's
It's
18.
0.
Okay, we got some conflicting answers here.
It is
Yeah,
0.
zero.
I picked this one for a reason. Are you guys even plugging into this right equation first? That's the first thing.
Yeah.
Okay, we've got this guy, -3 squared, right? This is how you plug him in. -3 only goes in for the x. The negative's on the outside. -2 times -3 plus 3. If you messed up on this part. You do not combine these negatives to begin with. No. You take -3 and square it, and that is
Oh, I think it's 9.
9. Then you apply the negative, right? This is -9. Okay, what's this come out to be?
6.
Plus 6 plus 3. What's -9 plus 6 plus 3?
0.
0. Okay, so the key there is whenever you see -x squared, the negative gets applied after you square it, right? Square the number first, then apply the negative. So that should be a negative number. Got it? Okay, so be careful of that, all right? They're trying to trick you with those. Okay, so that's just warming us up. All of these are quadratic functions. All of these are x squareds and stuff, okay? All right, go to graphing quadratic functions. Graphing quadratic functions, okay? First thing they have in 3 different colors is ax squared plus bx plus c, yeah? Okay, we have a is your leading coefficient. That is your quadratic term. Then B is the linear term, and C is what's called the constant term. He is just a number with no X on him. Yeah? A, B, C. We got it? Okay, now let's go down to, we have this function right here, and they have like different parts of it. Okay? So this is a parabola. They will all look like parabolas. Every quadratic function will be a parabola. Okay? You guys just said already that the vertex is that high or low point. In this case, it's the lowest point. And then another thing that we have is something called the axis of symmetry.
That's in the middle.
Axis of symmetry. I call them the AOS for short. Axis of symmetry. Your axis of symmetry will always be a vertical line so that you fold them in half, right? It's like the same folded in half. You guys know in art class where you guys used to paint on one side of the paper and you'd fold it in half and you'd unfold it and be the same? That's symmetry right there,
That would
right?
not be
Okay?
quite
We never
the same.
do
It wouldn't be quite the same.
This out order always be yelling at me because I didn't make
Yeah.
a little.
Maybe it was just yours, Brady, that was messed up.
It looked
Yeah,
a little
Brady,
bit.
it was.
It was just yours for sure that
It
was
looked
messed
like
up.
a.
Everybody else's looked fine. Yours was the only in there, right? Okay, Brady. All right, axis of symmetry, all of those things. Yeah, all of those things. Okay. All right, let's dive into a problem here. Oh, okay. Another thing. Let's go 2x squared plus 4x minus 3. Okay. All right, here's another example. Down at the very bottom of this page, before we flip the page, they talk about having a maximum or a minimum. So if I'm looking at 2 parabolas, how do you know it's going to smile or frown? Smile goes up, frown goes down. If your first number, the number that goes with your x squared, if it's a positive number, he's going to smile. If he's a negative number, he's going to frown. So this is an example of this, okay? An example here would be like -3x squared plus 6. Okay? -3x squared plus 6. Notice that this one doesn't have a b term. That's okay. You can have that, right? Now, if he smiles, going back to this one, shh, you got to listen. If he smiles, he will have a minimum point. If he frowns, he will have a maximum point, right? Do you get that? Like that just only makes sense, right?
Yes.
Okay? Depending on how he goes. All right, so let's go to example 1. Blah, 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 blah. Here we go.
Blah, blah.
Blah, blah, blah. All right, go to example 1. We're going to break this one down. We might, yeah, this is going to take a little bit of time to do. Example 1, they want us to graph this thing and then state the domain and range. Don't try to do the domain and range first. You have to graph him first, okay? So in the steps of graphing him, we want to make sure first he's in the correct order. Is he in the right order? Yeah. X squared, X number. He's in the right order, okay? Now we have to determine what A, B, and C are. A is the number in front of X squared. What is that number?
1.
If there's no number, it is 1, okay? B is this number. That is 2. C is negative 3. Perfect. Okay, now you have, they're going to have us solve for a couple parts here. So I'm going to write them up here in the top corner so that you can remember them. We have something called the y-intercept. Okay? The y-intercept is where he touches the y-axis. Okay? So when we have this function right here, x squared plus 2x minus 3, if you're trying to find an x-intercept, I think we've done this before. How do you find an x-intercept? Y-intercept. I'm sorry, y-intercept.
You plug 0 in for it.
You plug 0 in for x. If I put 0 here and I put 0 here, 0 squared plus 2 times 0 minus 3, what are you going to get?
Negative 3.
Negative 3. Guess what?
What?
Your y-intercept will always be that last term.
So
So C is always.
Well, that makes sense.
C equals always the y-intercept.
I was gonna ask why don't we put B for.
Does that make sense? What?
Well, as long as
Put
I
the
know
B
C,
for
I
y
can solve the
intercept.
problem.
No. What?
y equals mx plus
Like
b.
Y.
Oh, yeah, mx plus b, just because, I don't know, for in that case, like a lot of people say ax plus b instead of mx plus b, so it's just like a and b, I don't know, yeah.
Y
Okay.
equals mx plus c.
It should be y equals mx plus c, yeah, okay? But c is always going to be your y-intercept, that last term, kind of like an mx plus b, the last term is always your y-intercept, okay? That's always the way it works. So, if I go to graph this thing, negative 3 is where I'm going to touch at, yeah? Okay, now, couple other things that we have to identify, okay? If I'm trying to solve for the vertex, this is the little bit that you're going to have to memorize. Are you ready for this? It's a little formula, okay? Your vertex is going to be a coordinate point, okay? The vertex is going to be the coordinate point, okay? Where his high or low value is. This is what you're going to have to remember. Negative b over 2a.
Oh, we did
Okay,
this one.
negative b over 2a. Everybody repeat that. Negative b over 2a.
I hate this.
Okay,
I
negative
failed
b
this
over
one.
2a. That's what you have to use to find the vertex, okay?
No, I didn't.
All right, so I'm going to do that to this function. This is my function I'm trying to find the vertex for. Shh, you got to listen. All right, if this is the case, I want negative, what's my b value? From this function right here, what's b?
Negative
Negative
3.
No.
What?
B. What's b? This is b. This is a. This is c. Okay, let's back up. We're not listening. Shh, here we go. Negative b over 2a. I have my negative. The b value is 2. 2 times a. What's a? Nope. A is 1. Okay, you guys got to listen. We can go straight to homework right now. And we will here in just a minute because my patience is already limited. Negative b over 2a. 2 times 1 is 2. What's negative 2 divided by 2? Negative 1. Okay, so for my vertex, it's at negative 1 comma something. How do you find this something number?
Isn't that just your...
Plug that in for x.
You plug that in for x to solve, right? That's how I find. So then I'm going to plug in. So to find the vertex, I do negative b over 2a. That's the only thing I have to memorize. Then I just plug negative 1 in here to solve for the y coordinate, okay? Negative 1 squared, just like we just got done plugging in, right?
Negative 4.
Plus 2 times negative 1 minus 3. Okay, let's solve it. Negative 1 squared is 1. What's 2 times negative 1?
Negative 2.
Negative 2 minus 3. That becomes out to be, is Brady right?
I'm right.
Negative 4. So negative 1, negative 4. There we have it. Okay, I'm going to go down to my graph. So we have negative 1, negative 4. That's this dot right here. Okay, if I know this is my vertex, this is the lowest point. Right? That's the lowest point that I have. Now, if I know that's the lowest point and I know that my axis of symmetry goes through it, I can say that I know where that point's located, right? Because he's just going to be directly across. Does that make sense? Okay? And then what they've done is they've plotted 2 other points. So they said, what if x is 1 and what if x is negative 3? And we do that and we get 0. Negative 1 is at 0, negative 3 is at 0. And they've plotted those 2 points and we've got that. And then there's our parabola, right? Okay, one more thing. Let's talk about your axis of symmetry. So we had the y-intercept is number 1. He is always the last number. Number 2 is the vertex. He's negative b over 2a. Number 3 is the axis of symmetry, AOS. Here we go. Your axis of symmetry is this dotted line that goes through here. And your dotted line will always, 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 how often? Always go through the vertex. Always go through the vertex, okay? So, if this is my vertex, which is -1, -4, where is he going through the x-axis at? At x equals -1. He is cutting through x at -1 because that's my x coordinate, right? So your axis of symmetry is always going to be this guy right here, x equals -1. That's the way the axis of symmetry always, 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 always works. He's going to cut through this x coordinate, right? -1, x equals -1, that's that solid line that goes through there. Yes, sir?
These calculations are.
Be nice to Chucky.
Oh, no. It should be +1.
There's a dot on
That,
it.
I didn't put it on the right spot.
Really?
You're right.
There's a dot under your chin.
I looked at -1, not +1.
There is no
And on the
positive
back,
one.
not that.
Yeah, there is no +1. So this shouldn't be 0. +1 should be at 0.
Brady's back.
Actually,
There you go. If you want an actual point, +1 will be at 0.
They want to Brady's back.
Okay? All right.
Nice.
Let's go through and let's graph our own one. Oh shoot. I want an actual.
Yeah, I know. That's
I want
why
an
you
actual
like
problem.
rat head. I know it's that one.
you're a rat.
Oh, there's so many things in
Who
here.
keeps throwing erasers at me?
All right, example 2. Here we go. They're gonna have us write or like graph what this thing looks like. Compare the graph of f of x to a quadratic function with a y-intercept of -1
What did I do?
and a vertex at 1, 2. Which function has a greater maximum? Okay, so this is the function that they're giving me. This is not the one that they're talking about here. We're gonna graph the one that they're talking about there. We want a y-intercept of -1. So let's go down here. Y-intercept of -1, what does that mean?
He touches -1.
He touches -1 on the y, right? Okay, his vertex is at 1, 2. Plot him. 1, 2. This is my vertex, which means he has to smile or frown.
He's frowning.
He's frowning. He's going to go like this. Whoop. And go like this. Whoop.
Narrow.
And he's going to have another dot on this side. Do you see why I can see that?
Yeah.
Okay? He has an axis of symmetry that goes through the center there. No? No? Okay? So if this is the vertex, he has to be the highest point to the lowest point. Yeah? Okay? So he can't go like this, right? Because then that would make this is not the vertex. Does that make sense? So he has to be the highest point because he's got to go down from there, right?
Right.
And if he has an axis of symmetry here, this is 1 unit away from the axis of symmetry, so I can go 1 unit on the other side and put another dot. Got it? You see how that works? Yeah?
Yes,
Maybe?
I
Are you lying to me?
No.
No? You're good? Okay, so he's got to be a frowny face. So now we're comparing these two graphs, okay? What's something that we can do to compare? This guy's vertex is at where?
-4.
3,
6.
5. I think he's 3, 5. Okay? So what's the axis of symmetry? What's his axis of symmetry?
3.
X equals 3. Yep, x equals 3 is his AOS. Okay? The y-intercept for this guy is what? -4. Okay? So 0, -4 is on the graph. Okay? All right. Let's go down to connect the points with a smooth curve, blah, blah, blah. Okay. So when we have this, it says which function has a greater maximum? Which function has a higher maximum? The top one. His maximum point is where?
3, 5.
At 5 is his max, right? That's the highest he goes. Now, 3, 5 is the maximum, but we only go off of the 5, right? 3 is the tallest he goes. Okay, the bottom one? His maximum point is 2, so the one up above goes taller. He has 5 as his maximum, so he has the greater maximum. Got it? Comparing quadratic functions? Okay, here's what I want you to do really fast. We're going to go, let's do a homework problem together, shall we? Yep, we're going to do a homework problem together. Yeah, we're gonna. Okay,
Do you want to give us graphs?
I'm going to do number 6 with you, and then I want you to do number 2.
What are the 2, 4,
Wait, what?
2, 4, 8?
Okay, I'm going to add 6. Add 6 in there because we're going to do 6 together.
So
2, 4, 6, 8, 10. 2, 4,
4, 6, 8, 10, 14,
8, 10.
16, 20, 22.
2, 4, 6, 8, 10. Okay?
14, 16, 20, 22.
Okay?
14, 16,
Wait, what's the number?
All right, we're going to do number 6 together.
go at. Right.
8, 10, 14, 16, 26, 20,
Yep.
22.
Right here. There you go.
So kind to grab
There he is. There he is. Anybody else want graph paper?
No.
Yeah?
Marker?
Others?
It wasn't me.
Wait, graph paper.
Yes?
I didn't put it on my.
Graph paper, graph paper, graph paper, graph paper.
Okay.
You graph paper?
Graph paper.
Wow.
1, 2, 3.
All the graph paper.
Graph paper.
How many do we have to use?
Graph.
Graph paper. Graph paper.
Graph paper. All of you. Get some graph paper.
I was open once.
And some graph paper. Okay, Carson, you want some graph paper? Alright. We're going to do number 6 together, and then I'll have you do 2 and 4 for homework. How about that? So only 2 problems for homework. Here we go. Number 6. Let's go fast. Number 6, they want us to graph, and then we haven't done domain and range yet. Okay? So let's graph first. The first thing, I'm going to identify all 3 of these things. We want the y-intercept, the vertex, and the AOS. Those are the 3 things that I'm looking for when I'm graphing. Okay, so let's do it. The y-intercept for number 6
Plus it.
is,
3. 0, 3.
no.
It's 8.
The y-intercept is always that last number. So the y-intercept is 8. So I'm going to graph him. He is going to be 1, 2, 3, 4, 5, 6, 7, 8 on your graph. You're going to have to go a little bit higher. Sorry. Boop. Put him up at the top. 8 is his y-intercept, okay? The vertex, okay? Get used to remembering that formula. How do you find the vertex?
Negative 2b.
Negative b over 2a, okay? So, negative b, what is b?
Negative 6.
Negative 6. So I have negative 6. Do you see that? All over 2 times what's a? 1, okay?
Equals 3.
All right, negative 6 is positive 6 over 2, which is?
3.
Yep. Dylan said it. 3. Okay, now 3 comma something. How do I figure out what this something is?
1.
We have to plug it in, okay? So let's plug in 3. 3 squared is 9. 6 times 3 is 18. So 9 minus 18 plus 8.
Negative 9.
Negative 9 plus 8?
Is negative 1.
Negative 1. So 3, negative 1. I'm going to plot him. 1, 2, 3, negative 1 is this dot right here. That is my vertex. Okay? Now, the axis of symmetry always goes through that dot, right? Boop, boop, boop. So I'm going to draw my axis of symmetry. What's the equation for the axis of symmetry?
That equation.
X equals 3. Please make me happy and put X equals 3. Don't just put 3 because 3 is a dot. X equals 3 is a line. So X equals 3 is that guy, all right? So now I can see that this dot right here, which is on the left side, he has to also be repeated on the right side. You see that? So I'm going to put a dot right there, and you see what he looks like now?
8.
Whoop. Let me get a different color.
Maybe I know it.
Whoop.
Maybe I know
There he is. That's what he looks like. Do you see him? Perfect. Look at that. So we did those 3 things. Y-intercept, vertex, axis of symmetry. Okay? Then we have to do domain and range. Okay? All right. Maybe you remember this from when we did domain and range in chapter 1.
Oh.
Domain is the x's.
D is all the way
Hold on.
R is
Hold on. X's go left and right.
to negative 1.
Okay, so will this thing go to the left and to the right forever?
Yes.
Yes. So all reals for domain. Okay? The range is up and down. Will he go up forever?
Yes.
Yes. Will he go down forever?
No.
No. The y's are only
Greater than or equal to?
greater than or equal to negative 1. If we can look at this coordinate right here. Do you guys see this? Negative 1 is the y coordinate of the vertex. That's as low as he goes, right? It will always have to do with that coordinate, okay? So that's my domain and range. Have we solved all of the parts of the problem?
I think so.
Yes. Okay. all I want you to do, but I want you to do all of those parts for number 2 and number 4. You can do that for homework. Okay, just 2 problems, but I want them all to have everything. The y-intercept, the vertex, the axis of symmetry, grapheme, domain, and range. Whew, that was a lot. Okay, can you handle all that? I'll leave this one up. Let's talk about number 4 real quick, though. Blah.
Oh, we're doing number 4.
Blah. Now, we're not going to do it together. I'm going to start you, though. Okay, what's A? -2. What's B? Plus 0x. What's C? Plus 0. If you need to put those in there, go for it. Okay? If he's missing pieces, you put them in there. Got it? If he's missing any parts, you put 0 in its place. All right? You should be able to do that. Do vertex, axis of symmetry, y-intercept, grapheme, find domain and range.
I don't know.
For just those 2 problems, that's all for homework.
Wait.
Questions about that?
Wait, 2 and 4 is just homework.
Just do 2 and 4 for homework. Just do those 2. Don't do anything else but 2 and 4. Okay?
You remind me.
I will leave this guy up here.
Equation.
Do those really quick right now so you don't forget.
Okay.
So it's
Okay?
Let me
All right,
see.
I'm gonna pause. I'm gonna stop the video.